Hello, everyone. So this is another live session for Math1055. I believe it's number 9. So as always, feel free to ask any questions. I see there's something in the chat already about exams. Yes, we can talk about exams. What do you want to know? Well, the questions I'm not going to give you, but general questions about the exams. Yeah, I'm happy to discuss. But to be honest, there's not much to know at the moment. 2 weeks from now, so we have this session and 2 additional sessions. So week 10 and week 11, we'll have one of these live Q&As. So next week, week 10, we'll have the last proper lecture or live session covering the last bit of the core material. And the week after that, which is the last week, week 11, we'll talk about, well, we can discuss anything. I was planning to do some revision type questions, but you can also, yeah, we can devote an hour to discuss sort of exam-like questions, or, well, that's the same thing basically, but we can talk about whatever you'd like during that last Q&A 2 weeks from now. So if you have any specific questions related to the exam, I might be able to answer your questions. Use the chat as always. So are there any specific questions? In the meantime, we can go and solve some problems as usual. Okay, yes. So let me just put this up in the meantime. So you can go to itempool.com/math1055/live and input your answer to this question. We have 2 vectors in 3D space, and I'm asking about the cosine of the angle between them. Okay, and you can use the scalar products, the dot product, to calculate that. So, okay, so there's a question by Sam. How long will we have to do the exam? Yes, so, and there is the second question is basically related to that. So I believe it will be an open book exam, meaning that you will have everything at your disposal except each other. So without cheating, you know, and with you know, keeping in with the sorry, let me just start accepting answers. So the university has sort of some strict rules as to what you know, about plagiarism and basic a basic code of ethic, so to speak, and that covers sort of behavior during exams, even open book exams. So it will be an open book exam, and as far as I know, it means that you will have something like 48 hours. So there will be, my guess is that there will be a specific point in time in January when you will get the exam paper. And from that point on, you will have 48 hours to work on the exam paper, write down your solutions, and make a presentable, nice worksheet. And then, by the end of the 48 hours, the exam is over, and you will get an additional 2 hours on top of the 48-hour period, in which you have to upload your solutions, okay, your worksheet. So I believe that is how it's going to go. You get the exam paper, you have 48 hours to work on it, and then you have a 2-hour window to upload your work. And that's, I think that is immediately after the 48-hour period. So Elliot has a related question. Will the questions be written like homework part B or the online homework part A? So yeah, that's a good question. Since it's an open book exam, meaning that you can use the lecture notes and stuff like all of the internet, which is not something that you would be able to use during a regular exam. Normally people have 2 hours to solve all of the exam problems sitting in a room without being able to look at anything other than what they have learned. So since it's an open book exam, the problems will be, I would say, not necessarily more difficult, but not as numeric or not as easy as, let's say, some of the homework problems in part A. So in part A, usually you just had to input some number, calculate the sum of an infinite series or something like that. So, and that is easily done by any computer. You just go to Wolfram Alpha or whatever. I mean, I'm not giving away any secrets that you can basically just use computers to calculate any limit or sum or whatever I would give you as sort of a numeric type problem. So there will be less of that and more of the type where you have to generate an example, show your working, explain your reasoning, your answer, justify your answer. So much more emphasis will be put on the part of the exam where you actually show me that you understand what you have learned and what you are doing. Okay, so it will be very important in the exam that you explain everything you do, not just give me the end result like a number at the end, because a problem might be worth, I don't know, 10 marks, and just giving me the end result would be worth 1 mark out of 10, and all the rest would be rewarded for explanation and derivation and sort of detailed answers. So that is something that you have to be sort of conscious of. Okay, I hope that's helpful. So there will be lots of problems like, okay, give me an example of something, or try to think about something that is related to the usual stuff, but more creatively than just mindlessly calculating. Yes, okay, so I mean, if you look at the practice problems, you will definitely find the type of questions that will be in the exam. Yes, that's definitely true. So don't think that the exam will be entirely different of whatever you've seen. I wouldn't do that to you. I mean, the point is that if you have solved all of the homework problems, all of the practice problems, and you understood everything that was sort of involved in the solution of these problems, you shouldn't have any difficulties sort of solving the exam problems, the problems in the exam, and getting a high score. Okay, so there are a number of submissions to this first question. Again, I'm just asking the cosine of the angle between these two vectors, A and B. And here is the formula for the scalar product, the dot product of two vectors, which involves sort of the cosine of the angle between such two vectors. Maybe I should, I could close this one and quickly explain the answer. Don't worry if you couldn't submit your answer. There will be plenty of other opportunities. Okay, so yes, the answer was the cosine of theta is 1/3. And the way, well, probably there are at least 23 of you who could tell us how it went. But let me just quickly, well, see what these vectors are. So we have A written as a linear combination of our standard basis vectors. So I hat plus j hat minus plus k hat. So it means that basically it has the Cartesian coordinates 1, 1, 1, and B is quite similar except to A, except it has its last coordinate b minus 1. Okay, so just really quickly, so these are the two vectors. So this is something that we usually write as 1, 1, 1, and 1, 1, minus 1. Okay, so this is the coordinate, the triple of coordinates that we use to specify 3D position vectors. And there was this hint that the scalar product, the dot product of two vectors, is a number that you get by multiplying the length of A and the length of B and the cosine of the angle between the two vectors. So theta here denotes stands for the angle between these two vectors. But there was another way of calculating the same thing, and that was using coordinates. So if A has the three coordinates A1, A2, and A3, and B has the coordinates B1, B2, and B3, then this number, this scalar product, can be obtained if you just multiply the first coordinates, add to that the product of the second coordinates, and add to that the product of the third coordinates. So let me just number these as 1 and 2. So if I want to use 1, I would have to calculate the length of these vectors. Remember, that's nothing but the square root of the squared sum of the coordinates. Okay, so in the case of 1, that's just 1 squared plus 1 squared plus 1 squared under the square root. So that's root 3. And actually, the same thing is true for, well, we will get the same number for B, because if I take B1 squared plus B2 squared plus B3 squared, and the square root of that, in this case, is just 1 squared plus 1 squared plus minus 1 squared. That gives us plus 1 again. So all we have under the square root is just plus 3. So both vectors have length root 3. So that was sort of on the right-hand side of the first formula. Now for this, we can directly apply the second formula and simply calculate the scalar product, but basically just taking the product of the first coordinates, so that's 1 times 1, plus the product of the second coordinates, that's again 1 times 1, plus the product of the third coordinates, that's 1 times minus 1. So all we have here is 1 plus 1 minus 1. Okay, so 1 plus 1 minus 1. So that's 2 minus 1, that's just 1. Okay, so now we have the scalar product itself. So the left-hand side of these equations, it's just 1, as we have found. And we have almost everything on the right-hand side except of the first formula, except for the cosine of theta. So now, again, if I want to write down formula 1, I would write that the scalar product is equal to 1. And on the right-hand side, we have root 3 times root 3 times the cosine of theta. And from this, basically just root 3 times root 3, that's just plus 3. And dividing by 3, we get the cosine of theta. Okay, so this was a detailed solution to show you that the correct answer was indeed 1/3 for the cosine of theta. And of course, from that number, your calculator should be able to give you the exact angle, well, the approximate angle for theta in radians or degrees. I hope that was clear. Let's move on to the next question. So this one is again concerned with scalar products. So in this lecture, I didn't tell you, but we'll be dealing with scalar products and vector products, so dot and cross products. So Adam has a question: is the cosine of 1/3 irrational? You mean the angle that we get from this relation? Is it an irrational angle? Or yes. So I have no idea. Let me think. I think so. Why is that so? Why is that important? I mean, the cosine of 1/3. It's not a. I don't think it's sort of a value of the cosine that you get for some sort of well-known angle, some sort of nice angle in degrees. Of course, if you talk about radians, even the well-known values of the cosine are assumed at sort of pi/3 or pi/2 and places like that, which are all irrational points on the number line, irrational numbers. So I'm not entirely sure whether it's an irrational angle. I guess it might depend on might even depend on the units that you are using. Is it degrees? Is it radians? Okay, so the next question is, what is the geometric relation between the vectors A and B if the scalar product of A and B is equal to minus the product of the lengths of A and B? Okay, and we have four possibilities. We have A and B are perpendicular to each other, or A and B point in the same direction, or A and B point in the opposite direction, or the last possibility is A and B have an angle of pi/4 between them, and by that I mean pi/4 radians, which is 45 degrees. And again, I have this hint basically telling you how we calculate geometrically sort of the scalar product or the dot product. Okay, so we have something like 60 submissions. Let me close the poll if that's okay, and then we can see what you thought. Okay, so yes, it was option C, which says that A and B point in the opposite direction. Okay. So in the homework, Elliot is asking, in the homework for the scalar product, this sort of coordinate way of calculating it didn't work. Which homework? So which problem are you referring to? Homework 5, part A. Okay, and within part A, which problem are you? Because I don't remember all of them. Sorry, off the top of my head, I have to check, but I will certainly look into that. Is there different methods required? So there's really not many ways to go around calculating scalar product. It's either sort of this formula in the hint, which is involving the lengths and angle, or the coordinate representation. Of course, I'm not saying these are the only two ways, but for us, these two ways are the ones that should be used and should work when you would want to solve problems that I give you. Oh, by the way, let me just go back quickly before we start this one. So in case anyone was whoever weren't sure about this answer, so the general formula for the dot product or scalar product is this one, right? And the problem for us, well, in this problem, we had A and B such that the scalar product was minus the product of the lengths of A and B, meaning that we must have the cosine of theta be minus 1. Okay, and since the angle of two vectors changes between 0 and pi, so two vectors have an angle that is between 0 and pi radians. If you remember the cosine function, it starts from +1, dips down to 0 at pi over 2 radians, and further down to -1 at pi radians. Okay, so theta has to be pi, because now we restrict the function to to the interval 0 to pi, between 0 to pi. So theta was pi, meaning that the angle between these two vectors must be pi radians, or 180 degrees. So these two vectors could be like this. So this would be our theta, and they, as you can see, this means that they point in the opposite direction. Okay, they are parallel to each other, but they point in the opposite direction, and that is important when it comes to vectors. Okay, let's move on to the next question. So Elliot, I will look into sort of part A of homework 5, but if you could give me some details about this problem that you're referring to specifically, I could answer it better, I think. Okay, so this problem is to find this value of x written in the coordinates of A and B, such that A and B are perpendicular to each other. And the vector A has coordinates x plus 1 and 2, and the vector B has coordinates x plus 1, minus 3, and plus 2. And again, we are looking for x so that A and B turn out to be perpendicular to each other, and that there is a hint which says that two non-zero vectors are perpendicular to each other if and only if their scalar product is 0. Okay, so the question was A times B minus 3A. Okay, I have to look into this. Give me a minute and let me see if I can see this better. In the meantime, just try to find this value for x so that the vectors are perpendicular. So let me see. Oh, okay. I see. So there is in question 1, part B of the electronic or this Numbers component of the homework. There is something like A cross B minus 3A. So that multiplication is different to scalar products. Okay. So this is a good question actually. So I'll talk about this in a minute. But there are actually, as you might have seen in the lecture videos or in the lecture notes, there are, well, at least 2 ways, 2 different multiplications of vectors, 2 different ways of multiplying vectors, giving us completely different results. So there is the scalar product, something that has to be used in this problem as well, giving you a scalar, a number, if you multiply the 2 vectors this way. And there is the other way of multiplying vectors, the vector product, the cross product. So that's usually denoted by a sort of cross, an x between the 2 vectors. And in that case, as the result, you get another vector. Okay, so it's for a minute I didn't understand what you meant by A times B minus 3A, but the only way it can make sense is if A times B is actually another vector, because it's only a vector from which we can subtract another vector. Okay, so taking away 3A from some number, if A is a vector, wouldn't make any sense. But we'll get to vector products in a minute. I think it might be the next question already that deals with vector products, and I'll explain the basics. So we already have 50 submissions. Again, you just have to find the value of x such that A and B are perpendicular. Okay. Does anyone need some more time, or can we finish this one? Okay, I don't see anyone asking for more time, so let me finish this poll and reveal the answer. So yes, it was +1. So x equals 1 was the answer. I've seen some other solutions. There might have been some sort of calculation error. Let me just quickly go through this one as well. So basically, these are the 2 vectors that were given to us, as this linear combination of I hat, j hat, and k hat. So A had the coordinates x plus 1 and 2, and B had the coordinates x plus 1, minus 3, and plus 2. And basically, we wanted these 2 vectors to be perpendicular to each other, which for these non-zero vectors, which are definitely, so these vectors are definitely non-zero since they have non-zero coordinates, can only happen if the scalar product is 0. So if you calculate the scalar product, you know, in the usual way. So we multiply the first coordinates, so that's x times x plus 1, then add to that the product of the second coordinates, so that's x plus 1 multiplied by minus 3, and then add to that the product of this last coordinates, so that's 2 times 2. We should get 0. So we have to look for the value of x, so that that this equation holds true. So if we just simply expand everything, we get x squared. We get plus x from the first product, so x squared plus x. Then we get well, minus 3x minus 3 plus 4 equals 0, right? 2 times 2 is 4. So what we get here is x squared plus 1x minus 3x, so that's minus 2x plus 1 as the constant term. So what we have here is something that you, I hope you all recognize as being this complete square. X minus 1 squared is exactly equal to x squared minus 2x plus 1. So this has to be 0. We only get 0 by squaring the number if the number itself is 0. So x minus 1 has to be 0, meaning that x has to be equal to 1. Okay, so that was the quick solution to this problem. I hope that was also clear and made sense. Okay, so the next question, as I mentioned previously, deals with vector products. So it's different now. You have to be careful. It's a different type of product of vectors. Now we are taking the vector product of A and B, which means that we get a vector as the result. So it makes sense what's written there, that we are considering the length of the vector product. Okay, this is actually the reason why I use different notation for the absolute value of a number by just these single vertical lines, and the norm or the length of a vector by these double vertical lines or on both sides, to distinguish between sort of vectors and scalars. So the question is, what is the geometric relation between the vectors A and B if the length of their vector product, so A cross B, is a vector that has length equal to half of the product of the lengths of A and B? Okay, so and the options are A and B are parallel to each other, A and B are perpendicular to each other, A and B have an angle of pi over 4 or 3 pi over 4 between them, or last option is A and B have an angle of pi over 6 or 5 pi over 6 between them. And there is this very very strong hint or very nice help reminding you that the length of the vector product of two vectors is equal to the length of the first vector multiplied by the length of the second vector multiplied by the sine of the angle between those two vectors. Okay, so theta in this formula refers to the angle between the two vectors, A and B. Okay. So this is similar to the question we had, I think the second question we had, which was asking about the geometric relations of two vectors if their scalar product had some special relation to the lengths of the vectors. Now we have a similar situation where the vector product of the two vectors has an interesting relation. Well, its length is related in a very specific way to the lengths of A and B. By the way, so there are two different ways of two different sort of terminology or ways of referring to these products. So some people call the scalar product the dot product between two vectors, because the sort of the product symbol is basically just a dot between the two vectors. And some people call this product, the vector product, the cross product of the vectors, because it's across the multiplication sign. I personally prefer to refer to them as scalar and vector products, because in that way you at least know what to expect as the result. So the scalar product of two vectors is a scalar, is a number, and the vector product of two vectors should result in a vector. Okay, so but if you remember that there is this correspondence that scalar product is the same thing as dot product, and the vector product is the same as the cross product, then you are even better off, because then you know how to denote them and what to expect to get from these. Okay, I think there's been enough time so people can make up their mind. So let me just finish this one as well and reveal the answer. So yes, it was option D, so the last option. And let me show you why. So in case some people didn't get to calculate that. So in general, the length of this vector that you get by taking the vector product of A and B should be equal to the length of A times the length of B times the sine of the angle between A and B. In this problem, we had A and B such that the length of their vector product was half of the length of A times the length of B. Meaning that if you compare the general formula with this specific relation, in this problem we have to have the sine of theta being equal to 1/2. And again, now instead of the cosine function, we have to consider the sine function. And again, let me remind you that with the angles of vectors, we only allow for the interval for this angle to sort of change in the interval between 0 and pi radians. So, and the sine function is basically a hump between these two values, meaning that it takes the value 1/2 at two different spots. And these values, you might remember, are 30 degrees, so that's pi over 6 radians, or 5 pi over 6 radians, which is 150 degrees. So 30 degrees and 150. Okay, so since theta is restricted to this interval between 0 and pi, theta is either pi over 6 or 5 pi over 6 radians. Okay, I hope that was convincing enough and clear. So again, the point was that we had to see where sine of theta is equal to 1/2, and that's happening at two different places. Okay, let's move on to the next question. So again, you will have to use this formula for that we had in the previous question for the length of well, actually, never mind. What I'm asking is the length of the vector product of two vectors, and I'm giving you the two vectors as usual in this linear combination of the standard basis vectors, I hat, j hat, and k hat. So the question is, what is the area of the parallelogram spanned by the vectors a and b? And the vector a is I hat plus 2j hat plus 3k hat, and the vector b is minus I hat minus k hat. So you have the coordinates of each vector, and what I'm asking is this area of the parallelogram spanned by the two vectors? And you have this nice this nice diagram showing you these two vectors in sort of well, 2D drawing of the 3D situation, where we have two vectors in space and they span a parallelogram as shown. So it's shown in green. And in fact, sort of this is a nice geometric property of the vector product, that's so that the length of the vector product is actually equal to the area of the parallelogram spanned by the two vectors whose product you are calculating. So basically, in this problem, what you have to do is calculate the vector product of A and B, and then calculate the length of A cross B. So again, let me just say that in this problem, since you have the coordinates of each vector, you might want to look up the coordinate formula for the vector product. So how do you use the coordinates of the vectors to calculate the vector product? And then taking the length of a vector, that's already something we have done. Taking the square root of the squared sum of the coordinates is something that you have already seen in this lecture even. So in the meantime, let me just connect this problem to the previous one, where you've seen a different formula for the length of the vector product. So that was the product of the two lengths of the vectors times the sine of the angle between them. And you might remember from your earlier studies that a triangle, the area of a triangle can be calculated by multiplying the lengths of two sides times the sine of the angle between them, and take half of that. So if you don't multiply that by 1/2, this product, the two sides of the triangle times the sine of the angle between them, you get the area of the parallelogram that is spanned by the two sides of the triangle. So basically you get a parallelogram that you get by doubling the triangle, flipping it over the third side. Okay, so I'm guessing that you are busy calculating the vector product. So let me give you another minute to finish. Okay, so let me show you sort of the setup that we have here. So we have two vectors, A and B. A has coordinates 1, 2, 3, and B has coordinates -1, 0, and -1. And we want to calculate this, this vector product, which can be calculated sort of symbolically using a 3x3 determinant. Okay, so the way you calculate a 3x3 determinant like this, you might already know this. I think I showed you I definitely showed you the formula, the end result in the lecture videos, is that you go by the first row and basically take each element of the first row, so I hat, j hat, and k hat, and consider the corresponding sub-determinant, a 2x2 determinant, by basically covering the first row and whichever column you are considering. So if you take I hat, you are covering up these for the first row and the first column, and you have these 2x2 determinant left over. So that's 2, 3, 0, and -1 times I hat. Okay, so that's the first. That 2x2 determinant is going to give you the first coordinate of the vector product. Now onto the second element of the first row. So that's j hat, and for that one we have to include a minus sign, so it will alternate with plus, minus, and plus. So in this case, if we cover up the first row and the second column, so basically the row and the column of j hat, we are left with this 2x2 determinant consisting of 1, 3, -1, and -1. So 1, 3, -1, and -1 times j hat. And finally, with plus, we will have the coefficient of k hat covering the row and the column of k hat. We get 1, 2, -1, and 0. So 1, 2, -1, and 0 for k hat. And these 2x2 determinants can be easily calculated. What you do is just you multiply the diagonal elements. So that's 2 times -1, and subtract the multiple of the product of the off diagonal elements. So that's giving you the coefficient of I hat. Now with the minus, we get 1 times -1 minus -1 times 3. So that will be the coefficient of j hat. And last but not least, we'll have 1 times 0 minus -1 times 2. So it's it looks a bit complicated, but once you have practiced this with a couple of specific examples, you will get the hang of it. So what we have here is -2 minus 0, so that's -2I hat. Then we have to subtract -1 plus 3, that's +2, but with a minus sign, so -2 j hat. And last we have 0 minus -2, so that's +2 k hat. So the vector product has the coordinates -2, -2, and +2. So the length of A cross B is the square root of the squared sum of these numbers. So that's -2 squared plus -2 squared plus 2 squared. So that's 4 plus 4 plus 4. That's root 12. Okay, so let me see if people got that right. Okay, so root 12 can be also written as twice root 3, and yes, both of those inputs were correct. So I see our time's up. So I won't show the last question. It's actually not that important. Now that we know how to calculate scalar products and vector products, all you have to do is just practice these a bit more, and you will have no problem with these parts of the homework. Of course, next week you will get a few new lecture videos, as well as you will have the tutorial sessions, so you will see a few more problems being solved that are related to lines, planes, and spheres. Okay, so I leave you with that. Thank you very much for attending. I hope you all stay safe and have a good weekend. See you next Friday.